basically underwriting, sales, marketing, that kind of stuff. And then one day I decided to go technical because one of my interns kept telling me how cool Australia is. I thought that's really annoying. So yeah, like I can do the same. Yeah. So Melbourne Uni, master degree of actual science, 2 years. Yeah, and then I spent a year looking for jobs, and Allianz hired me. I was in Allianz for 2 years, responsible for a home product as a pricing analyst. And then recently I joined the IAG. Yeah. And today I'm going to talk about data visualization. So like the entire cycle of model building from exploratory analysis to data visualization, feature engineering, model building, model evaluation, and yeah, that kind of stuff. Okay, let's begin. So what is H2O? Oh, okay. So basically, today my focus is on H2O. So what is H2O? H2O is the open source leader in AI and machine learning. Basically, it's a platform where you can streamline, the bullet points I just covered, like exploratory analysis, feature engineering, model training, model evaluation. And you can go to their website, like this URL, if you are interested. And then first, let's load the packages. Okay, data.table is the main package for data manipulation. And ggplot2 is for data visualization, and H2O is the machine learning platform. Okay, so H2O, so like enhance the platform for better performance of R, and it has a lot of functions, but you can find most of the base R functions in H2O. You just simply add H2O dot in front of the base R function. Yeah, for example, AUC, the parity in H2O is just the H2O dot AUC. Okay, if you haven't set it up, if you haven't installed H2O, you should follow these steps. First, you need JDK. JDK is short for Java Developer Kit. Yeah, and it depends on your system, but most of the cases you will need 64-bit JDK. Version 13 and before, not version 14. Okay. After you got the JDK, you can install package by this command, install.packages H2O, and then you need to set it up in your terminal. Okay, I'll show you how to do it. Okay, because I'm using a Mac, okay, this is my terminal. If you're using Windows, you just tap CMD in your search bar, like the bottom left-hand side corner, and then yeah, you just command prompt in Windows. Okay, so 2 things you need to do. First, copy this line to the terminal. CD is short for change directory. And this directory is basically the location of this file. Okay, I'll show you. How can I? Okay, new screen. Okay. So yeah, basically it's the location of this file. h2o.jar. Okay. Let me switch back to the terminal. Okay. And then you just type java -jar h2o.jar, because I already set it up, so I don't need to run it again. And then if you want to launch H2O flow, you just copy this URL to your browser. Okay, let me switch to the new screen. This one. You guys see the browser? Okay, so H2O flow is very similar to Jupyter, but is a more ambitious project. You can just click through everything. Instead of coding, just click through everything, like import a file, split data, build a model, test your model, predict, yeah, things like that. Okay. Switch back to. Okay. And then this line is initializing H2O. And n threads equals -1 means that we're using all the threads, all the CPUs. Okay. So instead of using app-rate under data.table package, which is short for fast reading CSV file, we're using h2o.info file here. Yeah, you can look at you can have a look at the progress bar, and this data is saved as a hex format data set. If you check the type of air, the console set is environment. And then if you check is .h2o air, it says true. So basically, if the result of is.h2o air equals true, then this object is saved as a hex format dataset. Okay, so let's have a look at the parity in data table. Okay, the type of this object is called list. If you check whether this object is a data table, it says yes, and whether it's a data frame, and yes. So basically, if an object is a data table, it must be a data frame, but the reverse is not true. Okay, so let's go to the exploratory analysis. Okay, first let's check the dimension. So it says this data set has this number of rows and this number of columns. And let's check the name of the columns. So basically you receive a list. And then H2O has a very nice function. It's actually it's a Python function or Python style function, like h2o.describe. So basically it's summarizing all the important information of the columns. For example, what's the name of the column, the type, the data type. So for example, this one is integer, and how many missing? Are there any zeros? And positive infinity, negative infinity, minimum, maximum, mean, sigma. So basically standard deviation. Yeah. And this one cardinality. I didn't do research about that. You can have a look at this to figure out what it is. Okay. And then, and also use the default visualization function, for example, h2o.hist to check the histogram of a certain column. But sometimes it's handier to use data.table plus ggplot to package this combo. What we need to do is to change this object from a hex object to a data.table by this function s.data.table. Yeah. And then, for example, yeah, this is the histogram. Well, checking the histogram is very important in exploratory analysis to help you get a better idea of what's the distribution of a certain variable. And you also need to pay attention to the warning message. For example, this one says it has 1,195 rows that contain non-finite values. Yeah. Okay. You can also do something very fancy, like plotting the data points into this origin destination space and check whether it's arrived delayed. It's gonna take some while. So X is the horizontal axis and Y is the vertical axis, and color. So basically, this is telling R how to apply the coloring rules. Yeah, like this. So green means that it's not delayed. Sorry, it's delayed. And red means that it's not delayed. Okay. And sometimes ordering can help you get a good feeling about the distribution as well. And for example, in data.table package, we use setKey function. The first argument is the dataset, and the second argument is the column we want to order the dataset. And you can apply more than one. For example, you can also apply something like you can also do this. So basically, this is telling R to sort this dataset first by distance and then by destination. Okay. After that, we create a new column within this data table. Look at this dataset. Let's see a new column has been created. It's called order. So basically, it's the the row ID. Yeah, from 1 to 4, 3, 9, 7, 8. And then you can do a ggplot. It's a bit slow. Okay, cool. Now we have it. So, okay. Yeah, it's like this. And we can also do the same in the H2O package by this function, h2o.arrange. And if you want decreasing order, you just add DESC bracket around this variable. Yeah. Because it has some NA value. Okay, an interesting thing in H2O package is that when you sort the data set and if the column has NA values, no matter whether you want to do an increasing order sort or a decreasing order sort, the NA values are always in red. Yeah. So this function is checking the tail. So basically, the last few rows of the data set, because we have ordered this data set by decreasing order. So the tail rows are the smallest observation for this column. Okay. And we can do the same in data.table. So this object is a data.table. And okay, there's something you need to know. If an object is a data.table, so the most important structure is this structure, ij by. So I is basically the condition you want to filter and you want to check, and J is basically the columns. No matter you want to call the existing column or create a new column, and by is basically by. We'll cover it later. Okay. So within data.table, we can use this syntax to create a new column called unique ID from 1 to the maximum number of rows. And then, okay, this step is merging the original data.table and to itself, yeah. But then because we are only doing a proof of concept merge, so yeah, only 2 columns are selected. One is the merge key, and the other is okay, a proxy of the new column. Sometimes we need to merge on external factors. That's how we build the model. And yeah, we simply run this. As you can see, a new column is added to the data table. Because it has the same name as the original data set, there's a .y here to differentiate between the original origin and the new origin. Okay. In H2O, we can do the same, but then it's a little bit tricky because it's not very easy to create a new column in a hex format dataset unless we are using some functions, we are applying some functions to existing columns, but assigning some values manually is not very handy. So instead of this very neat syntax, we need to use cbind. So this function is used to combine 2 objects by column. Yeah. So this one is the original hex file, and this one, so basically we are changing a data.table object to a hex object, and then cbind them together. Yeah. And the syntax of H2O merge is exactly the same as the data.table merge. Okay. You can Google left join, right join, order join, inner join by yourself. It's very important, not just for R, but also for SQL, SAS, and Python. Okay, so basically everything if you want to merge a table, yeah, merge 2 tables together. Yeah. Okay, let's prepare response. As I said, if you are just applying a function to the existing columns to the hex file dataset, it's very handy. You can just use this syntax instead of using cbind. Yeah. The reason why we want to convert our response to numeric is because for most of the machine learning packages, numeric values performs better. Yeah. Next, I will cover a group by function. Group by function is very similar to pivot table in Excel and proxy array in SAS if you have used SAS before. Okay. So the syntax is like this. Okay. This is the data set, and this is the by variable. So basically, you want to summarize the data by this column. And then this is the first function you want to do after applying the by algorithm. So this one is calculating how many observations there are in each year, the number of rows in each year. And then this one is summing up the response together per each year. Yeah. So this is the result. Here, number of rows where the year equals 1987 is 1,999, and the total sum of response is this number, 1,700. And we can also do, we can also apply min function as well. Yeah. So it says for the year 1987, the average delayed probability is 0.85. Yeah. Okay. We can also replicate this logic in data table. Generally, data table syntax is much neater. Yeah, it's much shorter and yeah, it's easier to maintain. For example, as I covered before, if it is a data table, the most important structure is ij by. And I is the condition you want to apply, j is the column, and by is the group by variable. Okay, so in this case, when is arrived delayed equals yes, then is arrived delayed numeric equals 1. And when this condition is no, then this response is 0. Okay. And then this line is replicating this function. And okay, this line is replicating this function. Okay. Then we have the same. Yeah. Oh, something wrong here. Okay, I'll deal with it later. Yeah. But the idea is that we can use this syntax to replicate this function. Okay. And conditional filters is very similar to this example here. Yeah. The point is that we can use the same syntax in H2O and in data table. The syntax are exactly the same. Yeah. Okay. Let's do some feature engineering. Okay. So for all the rating factors, all the rating factors can be classified into 2 types. The first is numeric, and the other is categorical. And for numeric factors, we tend to, how to say, create some new numerical variables that contain the information of 1 or 2 or more variables. For example, in this data set, we have this variable called CRS arrive time. Basically, it's arriving time, and we also have this departure time. And looking at arrival time and departure time alone doesn't make sense because it's just a time. It doesn't give too much information. Instead, the travel time is more meaningful because it's the difference between the departure time and arrival time. And by creating this variable, we can safely ditch or drop these 2 variables. Okay. So this function is extracting how many hours, and this function is extracting how many minutes. And then by adding these two parts together, we have the arrival time in minutes. And then the difference between arrival time and departure time is the travel time. Okay, let's run the whole thing. Okay, for the categoricals, there are generally two ways of engineering that. One method is called one hot key, and the other one is called integer encoding. Okay, let's have a look at this example. Now we're looking at a destination variable within this data table, and has this number of unique observations. For example, ABE, there are 172 rows, ABQ, 188, so on and so forth. There are in total 134 unique destinations. Okay, so the idea of one hotkey method is applying something like, okay, if destination equals ABE, then we create a new column called destination ABE equals what? If this destination equals ABE, then ABE underscore destination underscore ABE equals 1. Okay, and then we do the same to ABQ all the way into the last one. There's a warning here. Don't run this line here, because the opposite of everything else is UCA. Okay. And in practice, there are many packages capable of doing this function. And yeah, generally it's a data.table, converting data.frame or data.table to a sparse matrix. For example, if we using this function, fact to sparse function, and the matrix package. Okay, maybe I need to run the whole thing. Sorry. Skip the visualization. And hopefully you can solve the problem. Where is it? Can't find it. Back to, oh, where is it? Yeah, here, got it. Yeah, as you can see, so if the destination is OAK, then the location in this sparse matrix is 1. The cell within this matrix is 1. Yeah, yeah. A sparse matrix looks like this. Yeah. Okay. The other method is called integer encoding. It's very straightforward. As we checked before, there are 134 different destinations within this data table. And we just do something like, if destination equals ABE, then destination underscore integer equals integer 1, and so on and so forth. So the difference between 1 and 1L is that 1 is saved as a float, and 1L is saved as an integer. Okay. Yeah. If you check the type, it says integer. This code is very ugly. In practice, we normally do this by, first of all, group the categorical levels together. For example, these are all the locations. Probably we can group them by states. You know, there are 50 states. Yeah, probably, yeah, 50 states in United States. And maybe you can also group them by whether it's in the metropolitan area or a rural area. Yeah. So grouping is basically reducing the dimension of your data set. Yeah. To control the complexity of your model. Yeah. Okay. And toy example is like this. So this data table or data frame has one column called brand, and two observations. One is called switch, and the other is PS4. And the idea of integer encoding is doing something like this. So if brand equals switch, then brand underscore integer equals 1, and PS4 2. Yeah. Okay. Now we enter the stage of model, splitting data set and model fitting. Okay. So my y is the response variable, and my x is reading factors, and we have both numerical factors and categorical factors. Yeah. And then we split the data set. Okay. If you look at this object split, you can see that it has two paths. One in double square brackets, and then two in double square brackets. And then we can call them separately by this syntax. Yeah. Okay. Now I need to talk about something about training, cross-validation. Hold on. Let me switch to a different screen. How can I do this? Okay. New screen. Okay. This is an illustration of a simplified model building process. So on the left-hand side, let's say this is a model of path 1. Oh, shit. Path 1. And on the right-hand side is path 2. This path 1, path 2 could be anything. For example, path 1 is model built by GBM or XGBoost, let's say XGBoost. And then this one is built by like GBM, basically two packages. So the idea is that before model building, we have no idea which packages perform better, so we test them. So the idea is that for the entire data set, first of all, we split data set into our model fine-tuning data set and our holdout data set. And then for the fine-tuning data set, we further split into training data set and validation data set. And this graph is an illustration of the idea for cross-validation. I'll type it here. Cross-validation. So that means, okay, this is a 4-round cross-validation. In the first round, we're using these 3 parts of our training data set, and then we test the performance on this validation data set. And then for the next round, we switch, and then we switch, and then we switch. The idea of doing cross-validation is to help you build a robust model that is not just significant for your specific split chosen, but is robust and relevant for the entire data set. Okay. So you use cross-validation to train your model, to fine-tune your model. And once you are happy with the result, Once the model performs consistently better, consistently good for all the splits, then you can finalize your model in this path. For example, this XGBoost model. This one is a light GBM model. Okay, then we reach a stage to determine which path is the better path. The idea is that, okay, so we retrain the model on the entire dataset, entire fine-tuning dataset. Okay, and then we compare the performance on the holdout dataset. If this one performs better, then we say, okay, XGBoost is the better path. Okay. Let's go back to the R code. Okay. This part is training a GLM model. Okay, this function can deal with both normal GLM and GLMNet. You can Google GLMNet if you're not familiar with that. Okay, so basically, the switch between a GLM and a GLMNet is done by these two parameter, alpha and lambda. Okay, the beautiful part of GLM model is that we can see the individual effects of individual reading factor, making it perfect to communicate with the stakeholders. For example, the product team, the marketing team, to give them a business in-house, like which kind of, let's say, which age group of insured is a better business, is more profitable, yeah, things like that. Okay, in comparison, GBM is a trade-based method, and you can't really see the individual impacts. Basically, it's a black box. The reason being that for the same reading factor, it could appear at different levels of your trade. For example, for the first trade, this variable is at the branch. But then for the second trade, it's at the leaf. So you can't really see the individual effects. But there are some techniques to deal with that. For example, you can use the guiding matrix. And then there's a package called SHAP, which is normally used in Python, but I heard it's possible in R, but I didn't check. Okay, you can have a look at this through this URL. And the categorical encoding method is controlled here. Okay, so one whole key means one whole key. Yeah, and then label encoder means integer encoding. After training the model, we can compare how to say the KPIs of the model. For example, because in this case it's a classification model, then we use AUC. AUC is for area under curve. So basically, it's a function of the true, positive, and false positive. You can Google it by search the confusion matrix. Confusion matrix. Yeah. So basically, AUC is a function of true positive and false positive. Okay, so it says for the training data set, GLM, AUC of GLM is 0.65 and GBM is 0.70. And for the validation data set, GLM is 0.64 and then GBM is 0.69. So it seems that GBM is better. Yeah. Well, generally tree-based method is better because the model doesn't have to be linear. It adds more flexibility to the model building process. Okay, that's the end of my presentation, I guess. Yeah, one last thing is that after some feature engineering and data cleaning, you probably want to output the data set. Okay, then you probably want to do this. So fwrite, it's a function under data table. It's very fast. So basically is outputting this data table object into a CSV. Yeah, that's it. Okay. Well, one last suggestion is that because machine learning techniques is always evolving, so what you have learned at uni probably will probably be obsolete when you enter the workplace, enter the companies. And the most important thing is that you keep learning new things. You must have an open mind and pay attention to the new trend of the technology. For example, H2O is a relatively new thing. Yeah, it's a newly created platform, but it has some amazing capabilities. For example, it has a better compatibility with other softwares, for example, Tableau. And you know, because in companies, sometimes you don't, you are not just required to build some models. Sometimes you are asked to build a process, and H2O is better because it has a better compatibility. And yeah, that's my key message. Okay, that's it. Thank you.
Okay, so that concludes the lesson of R. Thank you, Robert. If you guys have any questions, please be sure to ask us at the end. The next part, we are going to talk about Python. But first, let's take a short break